Hello, Algebra! Today, our learning goal is finding a and writing a function. So today we're talking about quadratic functions where there's some sort of a dilation, a vertical stretch or a vertical shrink. There are 4 steps you need to follow when there's a dilation in your function. First, you need to find the vertex. You need to write the function with the letter A in it, just as the letter A, because at this point you don't know what your dilation is. The second step is to find a point on the graph and plug the coordinates of that point in for x and y. The third step is then to solve for A, like you're solving an equation. And then your fourth step is to write your function. All right. So let's go ahead and look at this, and we are writing this function in vertex form. So this is our function. Okay, so first we're finding our vertex, and this is our vertex right here. So that is at 2, negative 1, 2, 3, 4, 5, 6. So our vertex is 2, negative 6. So we're going to go ahead and write our function. And we're going to put an A in the front where the dilation goes because we don't know what our dilation is. This would be x minus 2 inside the parentheses because you always do the opposite of the x coordinate. Since that's a positive 2, it becomes minus 2 squared. And then minus 6. So this means you had a horizontal translation, right 2, and then a vertical translation down 6. To give us our vertex of 2, negative 6. Okay, now you're going to look for some other point on the graph. It doesn't matter which point you pick, so I'm going to pick this one because I can really clearly tell what that point is. Since it's on my axis, it's easy for me to know the coordinates of this point. I don't have to guess. So the coordinates of this point are 0, and then 1, 2, 3, 4, 5, 6. 0, 6. Okay, now that I have my point, this is my x coordinate, this is my y coordinate, I'm going to plug those in for x and y in the function that I wrote. Now you could use any of these points on this graph. You can't use the vertex because that's already there, but you can use any of these other points and it will give you the same final answer at the end. So let's plug that in. So my y is 6, a is still a, my x is 0, and then you write the rest of your function. We do parentheses first, so 0 minus 2 is negative 2. We're just simplifying at this point. Then, still following order of operations, we have to do our exponents, so negative 2 squared. Negative 2 times negative 2 is 4. A times 4 is 4a, so this is now my equation. And now it looks like something I can solve. I can figure out what a is here. So I'm going to go ahead and solve that. I'm going to add 6 to both sides to get rid of minus 6, right here to cross that out. And I wind up with 12 equals 4a. And then I'm going to divide by 4. And I'm going to wind up with 3. So that means that my dilation is by a factor of 3. This is actually a vertical stretch by a factor of 3. So now I have my vertex, I have my A, I can write my final equation. So I'm going to go ahead and write it over here, and it's y equals 3 times the quantity x minus 2 squared minus 6. And this is my final function. So again, the steps I took to get that, I wrote my function using my vertex and the letter A. I found another point on my graph and I plugged that in for x and y. I simplified, then I solved for A and I found that A was 3. Then I went ahead and plugged in A and my vertex to get my final function. So then my final function is y equals 3 times the quantity x minus 2 squared minus 6. Notice that in your final answer, y and x are back to being variables. All right, let's look at a second example. Okay, we're going to follow those same steps with this second example. So again, the first step is to find the vertex. Here's my vertex right here. And that vertex is at negative 1, 2, 3, 4, negative 4, and then positive 1, 2. So we're at negative 4, positive 2. That's my vertex. I'm going to use that, and I'm going to write my function using a for my dilation. So this is y equals a times the quantity x plus 4 squared. Again, it became plus because when you're inside your parentheses, you always do the opposite of your x coordinate. It was negative 4, so it becomes a positive 4 in the parentheses, plus 2. So this is my function with my vertex using a to stand for my dilation. Okay, I know a is going to be negative because it's opening down. But I'm going to go ahead and just solve this. So I'm going to find some point on here. I'm going to use this one, I think. You can use any point as long as you can tell exactly what numbers it is. So right here, this is negative 2, 0. This is my x coordinate. This is my y coordinate. So I'm going to go ahead and plug those in for x and y. So for y, I plug in 0 equals a times negative 2 plus 4 squared plus 2. All right, negative 2 plus 4, I do what's inside my parentheses first. Negative 2 plus 4 is 2. So this is 0 equals a times 2 squared plus 2. I do my exponents next, so 2 squared is 4. So this is 0 equals a times 4 plus 2. It won't always be a 4 here. It just happened on these two examples, but this doesn't have to be a 4. A times 4 is 4a, so this is 0 equals 4a plus 2. And now you solve this. So to get rid of plus 2, I'm going to minus 2 on both sides. And I'm going to get negative 2 equals 4a. And then I'm going to divide by 4. And negative 2 divided by 4 is negative 1/2, or negative 0.5. So negative 1/2 equals a. I knew it was going to be negative because I can tell this is opening down, so I know a reflection occurred. An a of negative 1/2 means that it was a reflection in the x-axis because of the negative, and then it was a vertical shrink by a factor of 1/2. So now we're going to write our function. So this is y equals, I'm going to use negative 1/2 for a, because that's what I just found out it was. Put in my vertex, x plus 4 squared, and then plus 2. So I'm using my vertex, and what I just found out a was, my y and my x go back to being variables. Let's look at one more example. Okay, here's my last example, and again, I'm going to go ahead and follow those steps. So my vertex is right here. So that's at 1, 2, 3, 4, 5, 6. That's at 0, 6 is my vertex. So I'm going to go ahead and write this with a. So this is y equals a. Now I don't need parentheses because there's a 0 for my horizontal translation. So there's no horizontal translation, so we just keep that x squared. You don't need any number with the x because it didn't move left or right at all. And then plus 6 for my vertical translation. I know my a should wind up being negative because if you look, this is opening down, so I know a reflection occurred. I'm going to find another point on here. I'm going to go ahead and use this one, which is at 1, 2. So this is my x, y. And I'm going to plug those in. So y is 2 equals a times 1 squared plus 6. All right, 1 squared is 1. So we're going to have 2 equals a times 1 plus 6. A times 1 is just a. So now I'm at 2 equals a plus 6. I go ahead and solve that. I subtract 4 on both sides. Nope, sorry, I'm ahead of myself. I subtract 6 on both sides, and that's going to give me negative 4. So sorry. I hope that didn't confuse you. So positive 6 minus 6, that crosses that off. And then 2 minus 6 is negative 4. That's where that negative 4 was coming from. So negative 4 is a. This means there's a reflection in the x-axis because it's negative. That's why it's opening down. And the 4 means it's a vertical stretch by a factor of 4. It got taller and skinnier. So now you write your function. So we have y equals negative 4. I still don't need parentheses because 0 is in my vertex. So it's negative 4x squared and then plus 6. And that's my function. I hope this makes sense. If it doesn't make sense, please email me. Have a wonderful day, everybody.